Hey, welcome back to your favorite intermediate algebra course. We're going to talk about probability of independent and dependent events today. We're going to find the probability of both of those types of events. Okay, so if you look at the what an independent event means, two events are independent such that the occurrence of one has no effect on the occurrence of the other. Okay, so for instance, let's say you flipped, um, you're flipping coins, right? You flip a heads and you flip another heads, you flip another heads, you flip another heads, right? On the next time, and I know you're thinking in your head, well, it's about time for a tails. Well, what's the probability of flipping a heads on that last trial? It's still 1 and 2. It does not matter what you flipped on the other ones. Each time you do that, it's independent of the previous trials, okay? So the occurrence of one event has no bearing on the next time, okay? Now, dependent events are a little different, okay? And we'll talk about some of those. It depends, two events such that the occurrence of one affects the occurrence of the other, okay? So the classic example is picking some colored balls out of a hat and then without replacing it, okay? Or maybe drawing cards but not putting the card back or whatever. Okay, so let's talk about some independent events, okay? So if A and B are independent events, then the probability of both A and B will occur is probability of A times the probability of B. So what's the probability of getting a heads and a heads? Probability of a heads and a heads. Well, that's just the probability of heads times the probability of flipping a heads. And again, these are independent events. It doesn't matter. It's a 1 in 2 chance of flipping a heads. And on the second time, regardless of what the result was on the first time, when you flip it the second time, it's still independent of that. So still a 1 in 2 chance. So in other words, you got a 1 in 4 chance that you're going to get a heads and then flip another heads, right? So 1 in 4 chance. All right, let's look at the next one there. A game machine claims that 1 in every 15 people win. 1 in every 15 people win. What's the probability that you win twice in a row? Probability that you win and then you win again, right? These are independent events because 1 in 15 win every time on this game machine. So it's the probability that you win times the probability that you win. Okay, you got a 1 in 15 chance times 1 in 15. So 1 in, what is that, 225, I believe? 1 in 225 is 15 squared, okay? So those are some examples of, let's flip this to the next one here. Independent events. Here's some more. Married couple wants to have 3 girls. What's the probability that this occurs? Okay. So you might think to yourself, well, I have a friend like this. They had 3 girls, and then they were thinking, well, what's the probability that I have a girl on the last one, right? And, well, it doesn't matter what you had previously. It's an independent event each time. You still got a 1 in 2 chance that you're gonna have a girl on the last baby, right? So those are independent events. So if you're looking at this, a married couple wants to have 3 girls. What's the probability that they have a girl and then another girl and then another girl? Again, always independent here. So it's the probability of having a girl times the probability of having a girl times the probability of having a girl. Probability of having a girl is 1 in 2, 1 in 2, 1 in 2. So you got a 1 in 8 chance that you're going to have 3 girls right in a row like that. Okay. All right. What if you have a bag here? You got this bag, and you got in this bag, you got 3 red, you got 7 white. I don't have a white. I'll do that in black. 7 white. You got 5 blue marbles. Now you draw 3 marbles, replacing each one before drawing the next. Okay, so you draw one, but then you put it back. Okay, so this is independent because once you put it back, you still have 15 in the bag. Okay, so it's still an independent event. So once you draw again, it's just like you drew the first time because all 15 are in there. Okay, so what we want to figure out is what's the probability of drawing a red and then a green and then a white. Okay, again, each of these are independent, so it's going to be probability that you get a red times probability that you get a green times probability that you get a white. Okay, so there's 15 marbles in the bag total. 3 of the 15 are red. That's your probability of pulling a red. Now you put that marble back in, right? We put it back in, so we still have 15 left over. So it's just like I'm pulling clean again. So green, I have how many? Wait, what am I doing right in green here? It was blue. Whoops, sorry. That's supposed to be blue. This is supposed to be blue right there. All right, probability that you pull a blue. There's 5 blues in there out of 15. And then finally, probability that you pull a white, 7 out of 15. Okay, so this ends up being, what is that? Let's see, that'll give me 3 right there, and then 3 over 3 is 1. So I got 7 over 225. That's the probability that you get a red and a blue and a white. Okay, just like that all in a row. Okay. All right, now dependent events. So if A and B are dependent events, then the probability of both A and B occur is probability of A times, and you read this right here, you read that as probability of B given A. So given that A occurred. Okay, probability of B given A. So let's go back to this marble situation. Bag contains, let's draw this again. We got 3 red. We got 7 white. And then we got 5 blue. 5 blue, okay? You draw 3 marbles. Oops, that's supposed to say 2. You draw two marbles, sorry about that. Without replacing each one before drawing the next. Okay, so you pull it, and you leave it out, and then you pull another one. Okay? What's the probability of drawing a red? Probability of drawing a red and a blue, and again, this is without replacement. This is without replacement. Okay, so this is like probability of A and B is probability of A times probability of B given that A occurred. So assuming that A occurred. All right, so here we go. Probability of red and blue is probability of red times probability that you get a blue given that you pulled out a red. Okay? All right, so first of all, we pull out a red. Okay, we pull out one of these reds. What's the probability of that occurring? 3 out of 15 times. Now that we pulled a red out, right? Now you notice now you're going to have 14 left, aren't you? So what's the probability of pulling a blue given that the A occurred? In other words, given that red occurred. So you say, well, I got 5 blues left still in there out of, and I got 14, one less because I pulled the red out already. Okay, so we got 15 over 15 times 14. So 1 in 14 is our probability that this occurs. Probability that you pull a red and then a blue is 1 in 14. Okay, so that's without replacement. So without replacement causes that dependence because it depends on what you did with the first pull. Okay. Here's another one. Your teacher passes around a basket with 6 erasers, 9 blue, 6 red. So again, kind of like the marbles, 6 red. We got 9 blue and 7 green. Okay, so we got, is that 22 there? So if you and your 2 neighbors are the first to randomly select an eraser, what's the probability that all 3 of you select green erasers? Okay, what's the probability? So you're gonna pull out, and you want to pull out a green, and you're gonna leave it out, and then you want to pull out another green, you're gonna leave it out, and then you want the third dude to pull out a green as well. Okay, so probability of A, and I can write this out generic here, A and B, and you actually have a third event, C, would be probability of A times, oops, let me write this a little better here. Probability of A and B and C. Probability of A times probability of B given A times probability of C given, A and B. The A and B occurred here. Okay, the A and B occurred. So, here we go. Probability that you have a green and a green and a green. Probability of the green times probability of the green, given that you picked a green, times probability of the green, given that you got a green, and then another green. Okay? Alright, so probability that you get a green is, we got 7 greens out of 22, and now we've picked that green, so there's 6 left, and 21 of these erasers left, and then there's 5 greens left as your probability if you've already picked 2, and 20 erasers left. Okay, so this ends up being, let me punch this in, 0.023. Okay, last example here. You randomly select 2 cards from a standard 52 card deck. Find the probability the first card is a diamond, and the second card is red if, part A, you replace the first card before selecting the second. Okay, so with replacement. So this is a independent event, right? Because you take a card out, right? You're taking a card out. The first card's a diamond. Okay, and then you put it back, and then you're pulling again, and then you're pulling a second card as a red. Okay, so a probability of a diamond and a red. So we got probability of a diamond times probability of a red. Okay, independent again because you put the diamond back, so you still have 52 cards on the second pull. Okay, so how many diamonds you got? Well, we got 13 out of 52 here. How many reds do we have? So we got 2 suits are red, right? So 13 plus 13, we got 26 out of 52. So this ends up being, punch that in. 0.125, 0.125. Part B here, we got, now this is without replacements, so we're pulling out a diamond, and then we're leaving it out. And you know what, let me make this in red here. Red would be appropriate. We're pulling out a diamond, and a diamond color, by the way, is red. And then we're pulling out a red. Okay, so we're leaving the diamond out, right? So we have 51 cards left that we're pulling from. So probability of a diamond and then pulling a red, right? Would be probability of the diamond times probability of the red, given that you pulled out the diamond and you left it out, right? So this is conditional probability. So probability you pull out a diamond, you got 13 of those in one suit, 13 out of 52 times. Now remember that a diamond is red, so you have 1 less red now, okay? And you have 2 suits that are red, okay? Your hearts, I believe, and your diamonds, okay? So you have 26 reds, but you've already pulled 1 diamond out. So now you're down to 25 that are red total. And you've pulled a card out already, so out of 51. Okay, and this ends up being, let's see, let me punch this in here. 0.123. 0.123. Okay. Thanks, you guys. See you soon in class.